What is fluid dynamics? Fluid dynamics is the study of how fluids, liquids and gases behave when they are in motion. It encompasses the study of the forces that act on fluids, the ways in which fluids flow, and the properties of fluids that affect their behavior. What are the different types of fluids? Fluids can be classified into two main categories, liquids and gases. The behavior of these fluids differs because of their different properties. Liquids are relatively incompressible and have a definite volume, whereas gases are highly compressible and expand to fill their container. What is viscosity? Viscosity is a measure of a fluid's resistance to flow. High viscosity fluids flow slowly and are thick, while low viscosity fluids flow quickly and are thin. Viscosity is an important factor in determining the behavior of fluids in motion, as it affects how easily they flow and how much they resist deformation. What is laminar flow? Laminar flow is a type of fluid motion where the fluid flows in parallel layers with little or no mixing between the layers. This type of flow is characterized by smooth, predictable motion and is often observed in low viscosity fluids or at low flow rates. What is turbulent flow? Turbulent flow is a type of fluid motion where the fluid flows in a chaotic and irregular manner. This type of flow is characterized by eddies and vortices, and is often observed in high viscosity fluids or at high flow rates. Turbulent flow is much less predictable than laminar flow and can cause increased drag and energy losses in fluid systems. What is the Reynolds number? The Reynolds number is a dimensionless parameter that describes the ratio of inertial forces to viscous forces in a fluid. It is an important parameter in fluid dynamics because it helps to predict whether flow will be laminar or turbulent. When the Reynolds number is less than a critical value, the flow is laminar, while above the critical value, the flow becomes turbulent. What is drag? Drag is the force that opposes the motion of an object through a fluid. It arises due to the interaction between the fluid and the object and can be caused by friction, pressure differences, or other factors. Drag can have a significant impact on the performance of fluid systems and is an important consideration in engineering and design. What are some practical applications of fluid dynamics? Fluid dynamics has many practical applications in engineering and other fields. Some examples include the design of aircraft and spacecraft, the design of turbines and other fluid machinery, the study of ocean currents and weather patterns, and the design of heating, ventilation, and air conditioning systems. Understanding the behavior of fluids in motion is essential for optimizing the performance and efficiency of these systems.